Hello everybody. Today we're looking at 9.1, which would be solving quadratic equations by graphing. Now I'm not going to go over today how to graph the quadratic equations, because at this point you're good at that. We can do it, it's fine. We don't need to spend the time on it, and I'd rather the video be shorter and focus on the new information rather than reviewing that graphing aspect. So this should be quite a quick video, actually. It's just kind of emphasizing that idea that solving a quadratic by graphing is going to be the same thing as solving it by factoring. Okay, the answers that we're getting when we solve by factoring, and we say, I have a certain equation and I set it equal to 0, like this one right here. If I set that equal to 0 and I say solve and you factor it out, you get some x equals answers. Those answers are going to be the same thing as if you were to graph it and find answers that way. Okay, so we need to really emphasize the fact that the solutions to an equation, the x-intercepts of an equation, the roots of a function, the zeros, we need to really take all of these vocabulary words and really understand that they are synonymous, that they mean the same thing. Okay? Whenever you see these words in directions or anywhere else, they're going to mean the same thing. Okay, so let's start out in the beginning. A quadratic is a nonlinear equation, can be written in standard form, ax squared plus bx plus c. Okay, so we already knew that. A, b, and c are like coefficients. The x's are obviously part of the equation. So we learned how to graph them. Now let's take that information and start interpreting what it is that we're graphing. I have one equation here that says x squared plus 2x minus 3 equals 0. Okay, now I've gone through and I've got my graph. However, that's not what I was supposed to be doing in this example 1. What I'm supposed to be doing is solving this equation. So graphing it didn't necessarily solve it unless I know how to interpret that graph. So some of us may already have kind of gotten this idea, especially by saying that the solutions, the x-intercepts, the roots, and the zeros are all the same thing. You might think, okay, well, solve this equation. That means I'm looking for a solution. There's x-intercepts in this graph, so my solutions should be these points. And that's absolutely true. The solution to this equation, the x values that would make this equation true, are these 2 points right here. The point x equals negative 1, 2, 3, and the point x equals 1. Okay, I could have taken this equation, factored it down, and gotten a solution that way. But if I have a graph in front of me, it's going to be a lot easier just to say, whoop, whoop, those are my answers. Boom, done. Okay? Now, sometimes it can be a little bit trickier to find solutions graphically, because the graphs obviously are going to be moving around in the coordinate plane. They're not always going to have 2 solutions like this. In example 2, we look at one where there's only 1 solution. Okay? The graph has been shifted vertically upward to the point where if I look for x-intercepts in this equation, x squared minus 8x equals negative 16, well, first of all, you have to take x squared minus 8x equals 16 and put the whole thing onto the left side. X squared minus 8x minus 16 equals 0. Then you can graph. But once it's graphed, you notice if I'm looking for x-intercepts in order to find the solutions, I only have 1. And that's okay. Sometimes there is only 1. And how does that happen? I don't necessarily understand. I thought that every time that I factored these things down, I would always get 2 different answers. Well, like in this case up here, if I factored it, I would have gotten x plus 3 and x minus 1 equals 0, and then that would have given me my answers of negative 3 and 1. In this case, what I get here is x minus 4 times x minus 4. And we've seen this happen, where my answers, I do get 2 of them, but they're both the exact same thing. Okay? So I have technically one root, x equals 4, but it has what's called multiplicity, which means that it appears and it happens twice. So with multiplicity of 2. But I only have one solution here. In our last example, I have no solutions, no real solutions, and that's important. There are solutions there, but they are imaginary, and you'll get into that later. But as of right now, all we have to worry about is the real coordinate system and real numbers. So if I look at this one right here, I would have to say negative x squared equals 4x plus 5, or I could say x squared plus 4x plus 5 equals 0. Alrighty, so once I have this in standard form, I can go ahead and graph it, but when I go to find the x-intercepts, the roots, the zeros, the solutions, it looks like I'm not getting any x-intercepts. This graph is never going to cross the x-axis. So what am I supposed to do there? I have no visual to tell me where there are solutions, and that's fine. There are no solutions to this graph, no real solutions. Okay, and this word is very important. Please remember to try and keep in real in there. No real solutions to this graph. Okay, if you were to try and factor this and trying to find factors of 5 that add to 4, it wouldn't be possible. Okay, so just in summary, we can possibly have 2 real solutions where we have 2 x-intercepts. We can have 1 real solution where the graph kind of just barely touches and we have 1 x-intercept, or no real solutions where it never touches the x-intercept. Okay, and again, solutions, roots, x-intercepts, zeros, all mean the same thing. Okay, at this point we're going to go ahead and stop. I have an example 4 down here, however, the function is not shown up, so we'll do this one in class. But that's it for tonight, nice and short. Just keep all of this vocabulary in your mind and really try and solidify that.